So let's look at Pascal law in action. So we have a basic understanding of Pascal law. Now we're looking at one of its application. This is pretty much everywhere around us. Literally. Okay. So let's look at what I'm talking about. So the basic principle, if again, this is all in terms of your exams and everything, it's a combination of me exposing you guys to the application and also showcasing how to present the answer in your exams. So if someone asks, if the question is to talk about hydraulic pressure, the basic principle. So we are looking at hydraulic lift works on the principle of Pascal's law, or it can be explained with the help of Pascal's law, which states that when pressure is applied to a confined fluid, it is transmitted equally and undiminished in all directions throughout the liquid. In simple terms, this means that, so this is all that you guys can write. This need not be, so let me read through though. In simple terms, this means that any change in pressure at one point of the fluid is felt everywhere else in the fluid. Because pressure equals force per unit area, applying a small force. Okay, this part I'll explain. So yeah, basically you need to write this as the basic principle. So basically, how does your hydraulic lift look like? It's a very simple thing. It's something like this. It consists of two cylinders, C1 and C2. Say this is C2 and say this is C1. Right? You can clearly see that their areas are different or different cross-sectional area connected by a pipe. So we have a pipe. Both cylinders are filled with the same incompressible liquid and are fitted with frictionless watertight piston. So this has to be the case. So basically, if I apply a force onto the liquid, it has to transmit that force onto this piston, onto this cylinder without any leakage basically. So this is a perfect scenario. Now we have to assume few things. We need to consider, let me take up. This has an area of A1, this has an area of A2. Right? So actually, sorry, need that space. This has an area of A2. So before you push it, guys, they will be in equilibrium. That is, they will be at the same height. Maybe a bit more. Here, yeah, this is okay, I guess. This would be the initial scenario. So this is at a height of, it doesn't matter actually. So it moved from, the piston moved from point A to B. So this has to be delta x1 and this length is delta x2. Okay, so basically what I'm trying to tell is the cross-sectional area is A1 and A2. The piston from this height, if I push it down, say with a force of F1, it moves down by a depth to a depth of delta x1 and this moves up to a height of delta x2. Okay, that's what I'm trying to tell. So this is say F2. That's the force that this piston or this setup will experience. Okay, so it's a simple thing. We have a liquid in a airtight scenario. So we have cylinders or pistons over here. They're frictionless and they're airtight and all of that. So if I apply a force over here, this at this end, it will experience a force. So it's like pushing anything, if I take a rod and push at one end, the other end will also move. Something like that. But in this case, it's liquid. Okay. So that's the setup. So let's move on to the learning part per se, not learning. The other part. So what we are trying to do over here is we are trying to understand hydraulic lift in terms of force and in terms of work. So hydraulic lift in terms of force. So let's understand hydraulic lift in terms of force. So what is that we are looking at? Say if a force of F1 is applied at A1, the pressure is transmitted throughout the liquid, right? Through the incompressible liquid. Incompressible fluid. Actually liquid, because we don't use air per se. Actually, let me write liquid only. To the larger piston, to the other piston actually. Okay, yes. Now, so this is the very first statement. Next is, see, the pressure can't be different because pressure must be same at both ends. So that is P1 is equal to P2. Okay, that is what we have understood from all the Pascal's law and everything. So force by area has to be equal. Okay, do you guys agree? So from this, if I rearrange the force 2, right, force 2 is over here, it's over here. It has to be equal to A2 by A1 times of F1. So what can you tell from this? A2 is not the same as A1, or A2 is not A2, sorry, F2 is amplified by a factor of A2 by A1. You guys agree? So basically, in terms of numbers, if this is say 10 and this is 20, so if I apply a force of 4, this will experience a force of 8. I'm just applying a small force, but it got amplified. So if more, better the ratio, more the amplification. Of course, your delta x1 and delta x2 are not the same. So point here is I'm able to apply a small force and receive, or at the other end, it is able to experience a lot of force, right? So I'm able to lift something. Okay, let me put it this way. I'm able to lift something which I traditionally would have not been able. Physically can't, basically, right? So with a push of a button, I'm able to stop a bus. Now I'm able to use my leg and stop a bus. So it's as simple as that. A superhuman strength. It comes out because of hydraulic system. Okay, so that's what we are trying to show, and that happens because of this math. But how can I just do that? There has to be something that has to be balanced out. So hydraulic lift in terms of work. So let me go to this. So then it will make sense. Okay. See, as the liquid is incompressible. Right? And we have a airtight setup. And we have airtight setup. Volume will remain constant. Do you guys agree? So, thus, volume of liquid pushed at one end has to be equal to volume pushed at other end. Again, I'm writing the commonsensical stuff over here. So the volume can't disappear, right? So if I push liquid at one end, right? So here basically what I'm trying to tell is, here there was a liquid previously that got pushed and it got pushed over here into the cylinder, into the pipes. And obviously that same amount has to be lifted over here. If not, well, if not, there's no if not actually. It has to be so. If not, there is a leakage. Yeah, that can be the if not. So if this is the case, what can we tell? Well, then the volume 1, from here we can infer that volume 1 has to be equal to volume 2. So we know that volume is given by area into height, right? Area of cross section into height. In our case, A1 is displaced by delta x1 and A2 is displaced by delta x2, and they have to be equal. And when I rearrange A1 by A2, this will be equal to delta x1 by delta x2. So if I call this as 2 and I call this as, where is it? Oh, here. Not that actually. Doesn't matter. From 1 end to what can we tell? A2 by A1 will be equal to F2 by F1. So, is it? A2 by A1 is F2 by F1. Yeah. So, F2 by F1 will be equal to delta x1 by delta x2. This is from 1. If I rearrange, what will I get? F2 delta x2 is equal to F1 delta x1. So guys, what is force into this? What is this? Yes, work. Is it not? So basically work done at your cylinder 1 or piston 1 is equal to the work done at F2. So basically work done by F1 on the input piston, or okay, let me call this as input piston, is equal to work done by F2 at the other end. So you can see that we are not actually doing any extra bit of work over here. So the energy is per se conserved. That should have been your question. Like, how is that I'm able to put some effort and do a lot more work? We are not actually. So the work is not amplified over here. There's no external energy coming in. There's no external, there's no violation of law of conservation of energy. Okay. So in terms of work, we are not doing any extra bit of work. The system is not adding any work, right? All it is doing is amplifying the force. That is what you need to understand from this video. So what we are trying to look at is how fluid works, or using the fluid per se, or liquid in this case actually, how the behavior of liquid is able to help us in our day-to-day lives, right? So we have looked at a very simple case wherein we have a airtight setup, two piston with incompressible liquid. So a force at one end leads to some other X factored force at other end. That X factor depends on the area of cross section of the cylinders. So in terms of force, a small force leads to a very big force. That is possible. That's what we're trying to show. But in terms of work, there's no extra work added by the system. There's no external force or external source over here, right? So the energy is conserved. It has to be. So within the given system, there's no, the energy does not come in or go out, right? This is a small enough system for us to consider that. Okay, guys. So that's all we try to see over here. So now it's time for you guys to pause. Write what makes sense to you. Again, please don't write everything. What is needed, what helps you, just write that.